Hello all. In this video I am going to demonstrate a DC to DC converter. I am using 12 volt DC power supply as a voltage source. The 12 volt DC power supply is fed to an stable multivibrator using 555 timer IC. You can see here the 555 timer IC with two resistors and this frequency controlling capacitor. So it is in a stable multivibrator mode, the 555. The output of the 555 is fed to a 330 ohms resistor and it is fed to the gate of this MOSFET. So this MOSFET is oscillating at a frequency of 45 kilohertz. The output of this MOSFET is driving this transformer, the small toroidal transformer. The output of the transformer, the secondary of the transformer, is fed to a MOSFET again. This MOSFET is also triggered with the same 555 output. So basically the 555 output is triggering both the MOSFETs. Here in this video I am not using a Schottky diode. I am using a MOSFET as a switch, as a rectifier. The output of the toroidal transformer, the coil, is fed to a choke. This choke is absorbing all the high frequency signals and I am using a filter capacitor. This capacitor is 47 microfarad 450 volt. I am having the voltage rating more because I am not having the correct component right now with me, like 1000 microfarad and all. So whatever I got, I just put it as a filter capacitor. The output, as you can see, there is an LED that is glowing. So I am getting here, I can show you, I am getting here 28 volt DC. So if I check the frequency, just a minute, if I check the frequency, I am seeing no frequency present. So no AC component present in the signal. Okay. So I am getting a pure 28 volt DC. So if I select the AC, then what I am getting? I am getting 10 millivolt AC. So there is no AC component in the signal. That means I am getting a pure DC output. The voltage is 28 volt DC. The voltage is 28 volt DC, and this is because I am having a choke here, and this choke is filtering all the AC components. Okay, the capacitor is also bypassing all the AC components. So as you can see here, this is a small toroidal transformer. So this is based on the turns ratio. It is amplifying the voltage and it is also being switched with the IRF 840 MOSFET, and the gate of the MOSFET is connected to the same 555 IC, a stable multivibrator. So basically here I am not using a Schottky diode. Again I am going to say this because this is in this circuit I am using MOSFET as a switch. Both the switches are MOSFETs. The first switch on the primary is the MOSFET. See here you can see the first switch on the primary side of the coil is a MOSFET. The secondary coil of the switch is also, the secondary coil of the transformer is also switched by a MOSFET. Okay, so in this case we are using two MOSFETs, one in the primary and the other in the secondary. So in this DC to DC converter. Thank you very much. Thanks a lot for watching. Thank you. Please like and subscribe.